Okay,
Because it's half the length of that rod plus the R of the disc. So 0.7 plus half of 0.8. And
Oh,
it's also
okay,
1.1,
okay.
and then we square it.
yeah, okay. Got it.
This is all on what's called a rigid body,
Yes,
and we'll be going over fluid, or like fluid, whatever you call it, or
non-rigid body.
non-rigid. Yeah.
No, that
Okay.
non-rigid body is not something that you do in 151 or 251.
251 is the second.
251 is calculus based. It's this course, but with calculus.
Good to know.
With them, I would have taken one of these shapes and used calculus to derive it, as opposed to, hey, here it is.
Yeah.
How much more like in depth is the 251 compared to like basically like how much harder is it than this?
Well, if you understand calculus, it's not harder, but if you struggle with calculus or haven't had it, it'd be much more difficult. In terms of depth, there's, with calculus, there's a little less hand waving, or we dealt with a lot of situations where acceleration was constant. With calculus, you can now have a lot more accelerations not constant. I think there's a bigger difference though, however, between 252 and 152. There are certain points in the 152 where, I would say there's more points in 152 where you have to go, here's the formula, here's the situation, this is the formula you need.
Do people take this class before taking the 251 or?
Typically not. I've had some that I've had for 151, 251, sorry, 151, 152, 251, and 252.
So they take 251 first, like first physics class, or they take this class as first?
Most students in 251 did not take 151. But I will say most students in 251 had high school physics. I guess they did have a semester where half of them had high school physics, half had not. All right, let's see if we can look at sort of a conceptual approach to this. So I need to get the props. I had a really nice board, and then I got borrowed over the summer.
Borrowed or taken and, you know?
I said very explicitly that do not lose it or destroy it. And I have not seen it.
It's on the side of someone's house now.
It was a nice shelf. It was part of my inheritance from my mom.
Are you being for real?
Okay, it was hers. We were cleaning the place out. Makes it sound like we were doing something nefarious there.
No.
We were dealing with the apartment, my brother and I. My brother didn't want it. And I thought, oh, I could use it as a ramp. All right. Now something to roll. So let's start out with there we go. All right, so I've got a hoop and a solid disc. They have the same radius. If I roll them, which will get to the bottom first?
Solid disc.
Say solid will make it first? Why?
Well, I know they're going to be the same, but the solid disc would seem more appropriate since it has more mass. You know, you have less weight acting down on the ramp rather than with the hollow disc than the solid.
So you're going with more mass, the faster it'll go?
Yeah.
What?
The more mass is.
I would assume that the smaller one, or the one with less weight would accelerate easier.
There's a question in it's a CDL truck driver test, and the guy that was taking it, he said, you know, when you stop with a bunch of freight on the back of your truck, you actually have to account for the freight. But stopping with an empty trailer actually takes longer than stopping with a fuller trailer because it has more weight on the back of it. That's what he said. I didn't believe it.
That would seem to, unless there's something special about the truck braking system design, that just seems bizarre. All right, so first off, I want you to have an opinion about which one's gonna make it down first. And then we're gonna vote. We'll see if democracy works in physics. So we got the hoop, the solid disk, then tie, and then, for tradition's sake, I assume they both burst into flames on the way down. All right, so hoop will make it down first. Vote of one. Two.
The other one is,
The
has
solid.
more mass, right? Yeah.
Did you say this one has more mass?
Yes.
Okay. So he says this one has more mass. All right. So back to hoop down first. You're voting for the hoop? Hoop. And what is it? Who you? All right, so 3 for the hoop. The disc?
I want to say it, but I think I'm going for tie. I don't know.
A tie?
Yeah,
And no votes for neither. All right.
I should change my answer to neither just so we can have that on the board.
If they do burst into flames and I sort of discourage you from voting that way, then I will apologize after I put the fire out.
Spontaneous combustion.
All right. Now, there are a couple things that can affect it, the actual physical roll right now. One is I need to make sure that they both start at the same time. The other thing is that there might be some bias in the board if the board's slightly warped, or it's still a little bit off there. So I'm gonna do it twice. I'm gonna do it once with the hoop on one side and the disc on the other, and then I'm gonna swap spaces just to see if that makes a difference. Another thing is that I really don't want them to go flying across the room. Hopefully that will be enough, but potentially they're gonna hop that. Hopefully that's good enough. All right, so 3, 2, 1, go.
Okay.
Apparently the disc made that one. Let's swap just to see if there was board bias in that. I don't think so, but.
I freaking knew it, and I didn't even trust my own answer.
No one is right.
That's funny.
So democracy does not necessarily work here. All right. Anyone want to speculate why right now?
Because it has more, well, it has to do with friction, the amount of weight that's going down on the board into the slant, and how fast it can roll with that weight.
All right.
So,
I first want to comment about friction.
yeah.
I in order to do this properly, there should be no slipping at all. I am assuming an ideal roll
Yeah.
that the friction is not doing any work to the disc at all, because the friction should be static the entire time. In order to achieve that, I need the ramp to be low enough so that it doesn't get too fast and start to slip. But if it's, the steeper it is, the less the eccentricities of the board will have an effect, but the more it will slip and mess things up that way. So there's a certain Goldilocks aspect to the angle. So, but we are assuming that the friction is not having a significant effect other than getting it to roll. All right, so I interjected and forgot the other things that you said, so sorry about that.
You're good. The weight of it has to act down into the ramp. So, well, you said friction's kind of out of it, but it also in my opinion, it would have a little bit of help because the hoop is metal, which is less rough. You know what I mean? It has less chances for it to slide, or it has more chance for it to slide rather than that solid
All right,
disc.
so you're going with friction is playing a noticeable effect here.
That's one part, yeah.
Right. You wanna just feel to see which one feels like it's smoother?
Okay, they're both the same.
Okay.
So, is it because, the moment of inertia, like, since the mass is all concentrated on the outside of the hollow disc, they're both rotating around the center, so it has a greater moment of inertia, because, you see where I'm going with that?
So, yeah, oh, no, I see where you're going. All right. I'm gonna take what you have said and see if that makes sense here. So you're saying that this has a greater moment of inertia? That's what I heard you say.
Yeah,
You're hesitant whether you want to go with that or not.
yeah, no, I'm going with that.
Okay. So we need to figure out what the actual mass is of this. Really not a fan of using it, but then again, it might not be here, so. There it is, the electronic balance.
Well, we know it's at least one.
Pardon?
I said we know it's at least one.
1
kilogram. I always have this joke with my friends where they're like, "What is this?" And I'm just like, "Well, it's at least 4."
Okay. Is that one off? No, that's a balance. Oh, there we go. I hit the wrong button to start it. Now, this is called an electronic balance. Officially, it is actually a scale. You would get a different reading here than on the moon.
Hmm.
All right, I did it backwards. This is 216.6 grams. So 0.2166 grams. This is for the hoop.
Kilograms, isn't it?
Thank you. Made the conversion and forgot to do the units. The disc is 0.5285. Kilograms. The radiuses, radii. Should be the same. Radii for both was 0.05 meters. So, the disk formula, 1/2 mr squared. So that'd be 1/2 times 0.5285 times 0.05 squared. And for the hoop, the formula is mr squared, which is 0.2166 times 0.05 squared.
Why was the hoop just mr squared?
Because all the mass is equidistant, it's a distance r away. Or if you want to go with the fact that there's some thickness there, we could make it more complicated, but
Okay,
I was treating it like a cylinder where all the mass was the same distance away.
okay.
Technically, it's an annular cylinder, so there's an inner radius and outer radius, but that,
Okay, gotcha. So when it's solid, it has the same, well, it has differing amounts of, what is that, radii, would you call
Oh, if,
It's just a coefficient based on the distribution of mass.
it? Okay.
are you going with the fraction up front? Or the formula?
No, I was wondering why we didn't have a fraction in the hoop.
In that case, the coefficient is just one.
Okay.
You now have a fraction.
Well, I was I guess I'm not really understanding exactly, but is that because the hoop you said we were treating it as everything is equidistant from the center.
Right.
So for the solid disc, we'd assume that everything isn't equidistant from the center, or?
We assume it's not. I mean, it's a disk, it's clearly not.
Okay,
If this thickness here is small compared to the radius, it's a decent approximation to say, all right, we're gonna treat it like it's infinitely thin, same mass.
okay,
But officially, for an angular cylinder with some sort of inner radius, r sub I, and an outer radius, the formula for the moment of inertia is 1/2 m ri squared plus r outer squared.
okay,
If the inner and outer radiuses are about the same, then it's basically 2 times whatever that radius is squared. The 2 cancels out with the 1/2, and you're left with the mr squared,
okay,
which was the assumption I was making.
gotcha.
Anyway, do we get values over here?
I got 0.000264 kilograms meters squared. And 0.000542 kilograms meters squared.
Did you,
Is that not right?
did you flip it?
Flip what?
The values?
I may have typed something wrong.
From the zoom right there. This one should be the larger one, I would think.
The hoop is 6.60 times 10 to the -4th, and then the
Whoa,
You getting something different?
yeah. I got the .0054.
Yeah, I got that too.
For the first, for the,
With the hoop.
yeah, and then,
yeah, I did
I
do
got
those
6.6
backwards.
times 10 to the -4th.
I did those backwards,
yeah.
yep.
This is 6/6?
Yeah.
Okay, not
661,
661.
yeah.
All right. So, therefore, this has a higher moment of inertia.
Reason, because it had more mass.
Yeah, it did. I will say, Jacob, you're close. But you
Well-
did not word it right.
but if they were the same mass, then wouldn't the hoop be larger?
Yeah.
It would be.
Okay.
All right, let's take these 2 solid balls. This one clearly is larger. Clearly has more mass. Or if you don't believe it, I can hand them to you, and you can verify it. Which will make it down first? So let's get up the pole here. Small, large, high, and let's just go ahead and assume they will not burst into flames.
You know, it's funny. I still think this is a trick question, even though you just explained it to us. I still don't. I don't trust my gut that it's gonna be the bigger one.
Well, he didn't necessarily say that the moment of inertia is the deciding factor.
Yeah, but we just went over that. The bigger the mass,
Had the higher moment of inertia, yeah.
exactly.
All I said was he was close, I didn't say that he had it. All right, anyway, who says the small one's gonna make it down first? The large one.
Actually, I'm gonna go with the small one.
So 1 for small, 5 for the, no one thinks it's gonna be a tie. Okay. Now the trick on these, because they're round, they have a tendency to roll off to the side, so let's see if we can Come on, stop. All right, obviously, they're not starting in the same spot, please take that into account. All right. That
Blue
was-
wins. Yeah.
So close.
Gutter ball.
White's disqualified for coming off the board.
So I guess that was, neither did win, without bursting into flames. All right,
Whoa.
yeah. I'm gonna do this by hand. All right, so 3, 2, 1.
I should have done tie. I knew it.
So,
They have the same formula for the loss of inertia, right?
let me just also throw in, it's nothing to do with the color. So anyway, what are you saying,
I
Ian?
was saying they have the same formula for the moment of inertia.
They do have the same formula for moment of inertia. You stopping it there?
I don't know, I don't wanna say that that's the deciding factor. I can't really justify it, so I will stop there.
Does it have to do with surface area? Because the discs had a specific surface area. They were cylinders that had to roll on a specific set area, which also deals in with friction, but you know, the balls only had a specific amount of like a circular surface area that they would roll on at a given time. So would that have to do anything with it?
If the surface area for the first two was the same, in terms of actually touching and contact.
Yeah, but for the second one, what I'm saying is like, their surface area, is a circle, because they're touching the board at a circular, with a circular, what would that call it?
Circumference?
Yeah, well, on the board, what they're touching looks like